everyone, and welcome back to a fun and virtual day of learning in third grade. We are in science right now, and we're going to focus on magnets. Magnets have an invisible force that we're going to learn all about. You are welcome to follow along with us at home, just watching the video. If you have supplies at home, you're welcome to get them out and do them with us. If you wanted to do it at home, you would need some pretty strong magnets, you would need some magnetic metals, some non-magnetic metals, and then some other things like wood, glass, fabric, rubber, those kind of items too, to kind of test out their magnetism or lack of magnetism. But without further ado, we can go ahead and get started. If you want to do the experiment that we're going to do at the very end, you'll need a note card, a paper clip, a piece of string, and just some good old magnets. Now these are really strong magnets. One thing you can't do, you can't use like a fridge magnet. Unfortunately, it's just not strong enough and it doesn't work as well. You can give it a shot, it doesn't hurt, but I just don't know how successful you'll be. So I want to be able to at least model what to do. Okay, first things first, we're going to talk a little bit about magnets, okay? Magnets generate an invisible force field that is called a magnetic field. It actually kind of travels through the air. You don't know what's happening, but it's really, really happening. And you have magnets. Let's talk a little bit about magnets first, okay? We have magnets. Magnets have two poles. They have a north pole and a south pole. The opposite poles attract, meaning when I hold these magnets, clink, did you hear that snap? They clink together. So these poles right here are opposite, okay? Now, if I'm doing the same poles, all right, they're gonna repel, meaning if I flip one around, oh my goodness, I'm trying so hard. These must be the same poles because nothing's happening. If I try to push, I know it doesn't look like it looks like I'm not really doing it. I'm pushing super hard. You can see my muscles flex right there, okay? Nothing's happening right there. There's no way they're gonna clink together, okay? Those poles are the same and they're repelling each other. It's almost like they're fighting against each other because they don't want to click. They don't get along. So just know about magnets that they do have a north pole and a south pole. Your opposite poles attract and then your same poles repel. Let's go ahead and practice with some items. Let's start with some items that are magnetic. Now, if a material is magnetic, that means it has some kind of iron or steel in it. I'm going to go over some other metals that aren't magnetic, but you wouldn't know it. You think they were. So let's try some few things. I'm just going to use my magnet right here. Let's give this guy first. This is a good old-fashioned safety pin. Okay, right here. Boop. Oh, it clung to it. So this is this has a magnetic metal in it. It has some kind of iron or some kind of steel. Let's try some clippers. Okay, I see the clippers. Holy cow, it's stuck to that. Clippers definitely have some iron or steel in it. Oh, a battery right here. Look at that, it's stuck right there. A battery does have some iron or steel in it. The little spoon from Dollar Tree. Clink, totally worked. It has some iron or steel in it. It's definitely a magnetic metal. And then this is a binder clip. Okay, it's stuck. Magnetic metal. And last but not least, good old, okay, right there. That's just shaving cream. So clearly that has some iron or steel in it, which I wouldn't think. I would think it'd have more aluminum, but whatevs. Then we have some other metals that you might think, oh my gosh, these are clearly magnetic, but they're not. These metals don't have iron or steel and they have aluminum. And unfortunately, aluminum doesn't have magnetic properties. It can't attract like the other one. So let's give this first, okay, a penny. And it's gone. Epic fail. It didn't stick at all. It's totally fine. Let's look at our nickel. Same thing. Totally didn't work. Now, this is just it's adorable. Okay, it's got a little flashlight on it and everything. Okay, so just a hand sanitizer container. A cat, if you know me, I love cats. Let's try the metal on here. It's not sticking. Must be aluminum, so this doesn't have any iron or steel in it as well. All right, I know you've seen these before. These are your pencils. Nothing, didn't work. It has no iron or steel. It must be aluminum. All right, you guys all have these at home. Here's your Chromebook charger. Okay, nope, no magnetic metal in it. And oh, one more thing. Okay. Yummy Diet Dr. Pepper cream soda. Well, we all kind of knew that was aluminum, okay? Aluminum is not a magnetic metal, so it doesn't stick. Now, those are some metals to show you the differences between magnetic metals and not magnetic metals. But what about other items? Are other items able to stick? Okay, let's see what happens if they're magnetic. Okay, this is just a card, blank card, right? When I put my magnet up to it, nothing happens, okay? Not magnetic. How about Mr. Rogers? Mr. Rogers is plastic. Nope, nothing's happening. Eraser. Nope. Little Wolverine ceramic. Nope, I don't drop that, but it's not sticking at all. Here's some fabric. Cat ears right here. No, fabric's not doing anything. Okay, last but not least, ooh, this looks kind of shiny, like it might have metal in it. It's just, nope, it's not. None of those items have magnetic metals in them, so they won't stick together, okay? So those are some different things that you can try out, and I encourage you, try different things at home to see what magnets will attract to and what they won't. All right, the next thing we're gonna do, we're gonna try to see if we can make a paperclip levitate. Ooh. Well, Miss Beer, I have no idea what levitate means. Okay, levitate means to float in the air without any assistance. So we're gonna use the magical invisible force of the magnet to help this paperclip levitate. So here we go. Let's make some predictions before we do it. I only have a little note card. I have a magnet. And I got this string with this paper clip on it. Hypnotize myself. All right, how could I make this paper clip levitate? What could I do? I'm gonna give you guys just a second to pause and think. Just using your note card, this paper clip and string, and this magnet, how could you make this magnet float in the air? Not magnet, how could you make this paper clip float in the air? All right, let's see what we can do. All right, first things first, I'll try the note card in a minute. Let me see if I can just try to get this to work. Okay, well it's stuck. I knew that would happen because there's steel or iron inside this paper clip, so you guys can see it's sticking, but I want to be able to make it levitate. Oh, it's spinning, that's kind of cool. Can you hold it steady? Okay. Oh, maybe. See it kind of pulling towards it? Oh, wait a second, I have an idea. Okay, all right, let's try this right here. Do you guys see the space? Oh, it was there. Okay, do you guys see the space between the paper clip and the magnet? I'm able to make it levitate. If I move my hand, oh, there it falls. So let's try again. If I move my hand, it moves with me. All right, I was able to do it. I'm using the invisible force from the magnet called a magnetic field to make this paper levitate. Okay, pretty nifty. Now, I wonder, would I be able to use it through the note card? Let's give it a shot. Let's see what happens. Okay, so I'm just gonna take my magnet, I'm gonna put it on top like that. Let's see what I can make happen. Oh, sure enough, I'm able to. Even from the side, I can do it. From the top, I can do it. Even though there's a little barrier, I'm still able to do it. All right. I would call that a success. Pretty cool. So you guys got a chance to see what magnetic metals, how they interacted with magnets. You got a chance to see what non-magnetic metals interacted or how they interacted with magnets. And you got a chance to see what some other items did when they interacted with magnets. And a big takeaway from the day, just remember that magnetics generate an invisible force field called a magnetic field. And also, magnets have north and south poles. Opposite poles attract and same poles repel each other. That's pretty much all there is for today. We're going to continue our adventure with magnets in the next coming days. I hope you enjoyed this. I hope you were able to maybe get something new out of this, and if you had a chance, you could try some things out at home. If not, no big deal. And remember, at this end of this video, you should go ahead and click on the attached Google form. You're going to answer the questions on the form, and you're going to hit submit at the bottom. Remember, when you are done with all parts of this lesson, make sure you click mark as done on the assignment screen. That's all you need to do, right? I hope you guys enjoyed it, and I can't wait to work with you again. Have a great rest of your day.